category, you always are going to either be shifting vertically, which would be up and down, up or down, or you'll shift horizontally, which would be left and right. Yes? Okay? Dilations. That's like stretches and compressions. You're going to hear those words a lot. Stretches and compressions. They also can happen vertically, where you would take a picture and you'd kind of stretch it vertically, or you can stretch or compress horizontally, where you would kind of like pinch a graph and squeeze it in towards the y-axis or stretch it out. And then reflections also, again, are going to either happen vertically, where we would take something and reflect it vertically. So we would go over the x-axis, or flipping it horizontally, where you would go and flip something over the y-axis. So you'll always give the type of transformation, and you'll always give the general direction, whether it's vertical or horizontal, and then from there you'll be more specific about how far. So I then presented things in two different categories because I want you to see the difference, okay? Anytime you're shifting, something gets added or subtracted. So you'll always have an original function, and that's f of x in all of these cases. If I add or subtract after the function, that's vertical, okay? If I multiply, multipliers is what indicates a dilation. If I multiply outside of the function, right, in front of it, that's a vertical. And this negative is outside of the function. So when I talk about where is this happening, is it inside the function or outside the function? I'm asking you that because if anything is happening outside the function, in this case after, in this case before, in this case before, anything that's outside the function is vertical movement. Zach, are you with me? Okay, anything outside the function is vertical. Anything inside the function, look how these are written differently. Do you see that? I would read this one and say f of x plus 3. This one would be f of x plus 3. The words coming out of my mouth are exactly the same thing. F of x plus 3. But kind of where I delay in the way I present it is the difference. This is f of x plus 3. So we're adding 3 after the function. So that's outside the function, so that's why that's vertical. This one is f of x plus 3. So that's inside the function, within the function. Here is within the function. Here the multiplier is within the function. Same thing with the negative sign down here. So anything within the function is going to qualify as horizontal. So that's the first big point I want to make. What's vertical, what's horizontal, and how do you tell? Outside the function is vertical, inside the function is horizontal. Okay? From there, it's be more specific about direction. So this is a shift because it's addition. It's outside the function, so it's vertical. And specifically, you have to say, is it up or down? And if you add 3, what's your instinct tell you? Up or down? Up. So this is a shift vertical, and I'll let you use V or H for horizontal. So shift vertical, and then be more specific, up 3. This one is subtraction, so that's shift. It's after the function, so it's also vertical. But when you subtract 3, what do you think? Down. So that kind of follows your logic. Let's go down to this one. It's a multiplier. Anytime you see multiplier, it's a dilation. And it's outside the function, so it's vertical. And specifically, do you think this, if you multiply by 3, do you think it stretches something vertically, or do you think it compresses something vertically? Stretches would make logical sense. So dilation vertically, stretch by 3. So everything becomes 3 times kind of the size. If the multiplier is a fraction less than 1, it's still a dilation because we're multiplying. It's still vertical because it's outside the function. And it's a compression by 1/3. And lastly, anytime you see something negated, okay, that's a reflection. So there's a negative. It's out in front of the function, so it's vertical. And you can be more specific here and say over what axis. So a reflection vertically over, if you reflect something vertically, so let's look at this pencil. If I reflect it vertically, which axis did I just jump over? Going from here to here, you jump over the x-axis. Okay, so you just have to get used to pluses and minuses meaning a shift, multipliers meaning a dilation, and negations being reflections. Okay? Outside the function, and all of this happened outside the function, was all vertical, and then be more specific. And these all you kind of get instinctually. Okay? So if we look at these, I kind of tried to keep them exactly the same for the most part, meaning the same numbers, but trying to highlight why it's horizontal. Okay? There's still a +3, so it's still a shift. Anytime you add or subtract, it's still a shift. But because this +3 is happening within the function parentheses, that's horizontal. Now, horizontal means left, right. So what would your instinct tell you if you're adding 3? Would that tell you left or right? Right. Now here's the killer about horizontal movement. Whatever your instinct is, it's always the opposite with horizontal. So we would think that +3 means to the right, but it actually shifts it left 3 when you're adding. And vice versa, the next one, still a horizontal shift. When you subtract, you would think that means to the left, but it actually is to the right. So when you think horizontal, think, that's the screwball one. That's the one that's the opposite direction of what you would guess. The same is true for the multiplier. It's a multiplier, so it's still a dilation. It's still horizontal. Would you think that's a stretch or a compression when you multiply by 3? Wouldn't you think stretch? But it's actually a compression here because we're in the horizontal column and everything is screwy. Compression by 3. F of 1/3 x, it's a horizontal dilation again. And again, 1/3, you would think that would compress, but it's in the horizontal category, so it's actually screwy, and it's a stretch by 3. Or stretch by 3. You almost like triple everything, you're stretching it. And then when you negate something, we're still reflecting. You're reflecting horizontally. This one can't really, there's no number involved, so it's not really as, screwy as those two. But if I reflect something horizontally, what axis am I going over? The y-axis. So anytime you describe a transformation, I need the type, shift, dilation, or reflection. I need vertical or horizontal, and I need then more specific information. If it's vertical, up or down. If it's horizontal, left or right, kind of thing. Okay? All right. So what does this look like? Like, let's look at example number 1. here is the g of x function. It didn't really copy great, but there it is. Okay? And first of all, is this a shift, dilation, or reflection? Shift. Micah, you with me? Because it's plus, it's a shift. Is it vertical or horizontal? Cameron? Vertical, because this plus 3 is happening outside the function. It's not within the function, it's after the fact. So that's vertical. And specifically, the plus 3 means up 3. Okay? So that if this is g of x plus 3 is going to look like the exact same thing. It's just every point is shifted up 3 units. So I'm going to take this point right here, shift it up 3. I'm going to take this critical point. Any kind of corner is a critical point. I'm going to shift that up 3. 1, 2, 3. I'm going to take this one, shift it up 3. And I'm going to take this one, shift it up 3. And then I'm going to connect those points. And I'll also label. This is my g of x graph. This is my g of x after we've added 3. Shifted it up 3. Okay? I'm going to skip the rest of these. I'm not going to actually draw the graphs out, but just as a quick check for comprehension, what would be the transformation on exercise 2? Take a minute to process what's going on there. I want to know the type of transformation, the direction of transformation, and then the magnitude, meaning how far. Andrew, what do you think about number 2? It's not vertical. See how that plus 3 is happening inside the parentheses? And when you be more specific about which horizontal, is that a left or a right? Left 3 units, yes? It's a shift because of the plus. It's horizontally because of the inside the function. And it's left 3 to be more specific. So you would take all those critical points and shift it left 3 and the whole graph would slide over 3. Okay, exercise 3. What do you think, McKenna, on that one? Perfect. Shift. Oops, shown. I was combining shift and down. Shift, vertically, down 3. And the last one, Nate. Shift horizontally. I'm sorry, I didn't hear. Very good. Right 3. Excellent. So without doing those graphs, I just wanted to talk about those, okay? All right, flip over the back. We have a couple more random ones. And you may need to keep flipping back to the front to figure it out. Take a second to think about exercise 5 and just describing what that is first. Kirsten, what do you think? Okay, shift and dilation are 2 different things. So which is it? Dilation. It's a dilation because it's a multiplying by 2. It's vertical because it's happening outside the parentheses. And it's a stretch or compression, did you say? Stretch by 2. So how to visually do this, okay? Everything stretches or compresses away from the axis. So in this case, that would be the x-axis. So this point is currently 2 units away. What happens when you double that? Because we're multiplying by 2. What's 2 times 2? 4. So that becomes 4 units above the x-axis. Okay? Our next critical point is this one. Look up at the graph. That's 2 units below. So if it's below, it's going to stretch away from the x-axis going below. So it's 2 units below. Double that, it's going to become 4 units below. This next critical point is 1 unit above. Double that, it's going to be 2 units above once you stretch it. And the same thing for this last critical point. It's 1 unit above the x-axis, so when you stretch it, it's going to become 2 units above. So you almost think when stretch and compression, kind of think of that as like a rubber band. And then everything got stretched, so it's just much steeper. Everything got kind of stretched away from the x-axis. Yes? Notice that a point that was on the x-axis to start is still on the x-axis. Right? If you're 0 units from the x-axis and you stretch double, you're still 0 units away from the x-axis. Does that make sense? Okay. On this one, what would be the, think about it for a minute. I want the type, the vertical or horizontal, and then the specifics. So Aiden, is this a shift, dilation, or reflection? Dilation, horizontal or vertical? Very good. And be more specific. Is it a stretch or compression? Compressed by, good. By 2 or by a half, you could kind of go either way with that. So now I'm horizontally compressing. So whatever's out here is going to squeeze in half the distance towards the y-axis. So now if I look at this first point, it's 3 units away. What's half of 3? 1.5. So that gets compressed into there. This one's 1 unit away, so half of that is compressed into here. This one is 2 units away from the y-axis, so it's going to get compressed in a half. And this one is 3 units away, so half of that is 1.5. So everything got smushed in from where it originally was. It's just pushed in. Does that make sense? Okay? So without actually graphing number 7, what is it though? Let's describe it. Maybe Connor can take a stab at it for me. Let's start with shift, dilation, or reflection. Dilation, horizontal or vertical? Vertical. Compressed by, yep. So if you look up at the board, visually what's going to happen is this is just going to squeeze in, vertically squeeze in towards the x-axis by half. Yes? Exercise 8. John, what do you think? Is it horizontal? Great, because it's within the function. And I don't know why, stretch by 2, because like saying stretch by 1/2 doesn't really, but you're really stretching it by 2. So horizontally here, this is all going to double its distance away, so it's just going to get wider. Not taller by any stretch, but wider by that stretch. Okay? Make sense? Exercise 9. Think about the description here on your own for a minute. And Kaylee Smith. Very good. Vertical will always be over the x-axis. It's a reflection because it's been negated. It's vertical because it's out in front. So let's do this one. If this is 2 units above the x-axis and we're flipping it over, now it's got to go 2 units below the x-axis. So that goes right there. This next critical point is 2 units below, so it has to flip to 2 units above. This next critical point is 1 unit above the x-axis, so it's got to flip 1 unit below. And the last critical point here, I'm going to draw that a little more clearly, is 1 unit above and also flips 1 unit below. So we get that image. Does that make sense? There was our original g of x. Here's g of x after it's negated. So you see how the x-axis is a line of symmetry between that crazy thing? Yes? Okay. And then lastly, we have a reflection again, because it's negated. It's within the function, which will always be horizontal. And horizontally flip over the y-axis. Okay. Any questions on that? The last thing I have to throw at you, because we've been doing one transformation each time, is that realistically you can do multiple things. Okay? So in this particular problem we've got really 4 things going on. The negative, the 2, this -7, and the +1. The order of transformation is important. Okay? First of all, you're always going to work from the inside out. So we would always start by describing what happens within the function first. So any horizontal movement occurs first. Is that clear? Okay? Because it's within the function. So specifically, what is happening with that -7? It's a shift. So I'm going to do kind of step 1, a shift. It's within the function, so it's horizontal. And tell me specifically, Evan, which direction? We're just focusing on this f of x minus 7. Hold on, Evan's helping us. Who just told me that? Maggie. Pretend you didn't hear. To the what, 7? Does that make sense to you, though? Okay. So, right 7 units. So that's the first thing. Now, think about order of operations. What would you do next? Would you multiply by -2 or would you add the 1? Maggie? Right, you would multiply by -2. Now, because that's a negative number, there's 2 things wrapped up in there. There's the negative part, which is a reflection, and then there's the multiplier of 2 part. Okay, so it's actually 2 different things happening within that coefficient. The order of those 2 things doesn't matter. So I'll start with the negative. So it's reflected. That negative is outside of the function, so it's vertical, which always would be over the x-axis. Then step 3, I'll deal with the fact that we're multiplying by 2. So it's a multiplier, that's a dilate. It's out in front again, so it's vertical. And it's a stretcher compression. Mason? On this 2. If I'm multiplying, which stretch by 2, very good. And then the last thing we're going to address is the +1 that's happening after the fact. It's plus, so it's a shift. It's outside the function, so it's vertical. And specifically, if it's vertical shift, is it up or down? Up 1. Does that make sense? Okay. Exercise 12. Last one here. If you were describing, without me, what would you say comes first? Other Kaylee, not Kaylee Smith. What's your last name? McCadden. What would you describe first as your first transformation? Okay, so what would you write? A horizontal, what? Start with one of those keywords. Okay, a dilation, horizontally. Now your specifics. Yep. A stretch by. We're going to leave the negative out of it. The negative is a separate transformation, right? We're just going to deal with the 1/5. It's a stretch by 5. Okay? You always reciprocate that. And I actually think I screwed that up on the front. On this 3, can you do a dilation horizontal compression by 1/3? Because these horizontals get reciprocated. Okay, so that's good for the first one. So she handled the 1/5. So that's done. Next we have to handle that negative. So Nathan H., what would you say for that? Over what axis? Very good. So that handles the negative. That touches everything inside the function. What would you say next? Zach? A dilation. Yep. Horizontal or vertical? Okay. Stretch or compression? Compress by 5 or 1/5. Honestly, I would take either because it's kind of like one of those. So he was addressing the 1/5 out in front, which was correct. And then lastly, the -2 at the end. Oh, Madeline. Shift. Vertical. Beautiful. One quick thing to help you guys when you're listing these out, all your H's should come first, right? Doesn't that make sense? You're working inside out. Anything horizontal comes always first, and then address your vertical. Good? You may do this homework on this separate sheet of paper too, because there's like a lot of graphs that you're going to have to kind of shift or stretch. Does that make sense? And then once you have to graph them on a separate sheet of paper, so right on top of the current graph, just kind of draw the new one in the right location. Does that make sense? So for that reason, you can do the whole homework on. If you feel like you need a separate sheet of paper for space reasons, you're welcome to do that. I can. I didn't. I'm free right now, so I am going to do that right now.
From that to this period.
Okay.
Because I really do need to.
Right. You know what I'll also do? I'll put it online.
Okay.
I'll put it on my webpage.
Thank you.
So if I'm not here, you're welcome. Yes, Andrew just asked me. I have it. Do you guys have? Can I email it to you? Actually, better yet, I'll put the link on my webpage right now. How's that? Oh, okay.